Okay, welcome to section 1.2, Analyzing Categorical Data. In this section, we are going to be specifically looking at categorical data. So just keep in mind that categorical data, the categorical variable are always going to be the labels for the various categories. So once again, think about your bins and the fact that the categorical variables are going to be the labels for each of your bins. So labels can include examples such as male, female, color of hair, color of eye, blue, green, red, color of M&Ms in the bag. Just remember that it's anything that cannot be analyzed mathematically. In this section, we're going to look at the distribution of a categorical variable. Any distribution of a categorical variable always lists the categories, and within each category gives the count or the percent of individuals that fall within each specific. Okay, so in this section, you're going to be able to construct and interpret bar graphs and pie charts. They will show you the distribution of the categorical variable. Understand the difference between good and bad graphs, so making sure that you have a good graph that can demonstrate the data that you are trying to display and interpret. You're going to construct and interpret two-way tables, and we'll go over what that means. Be able to describe the relationship between two categorical variables, and begin at looking at how to specifically organize statistical problems. Okay, so as I said at the beginning of the first slide, categorical variables place individuals into one of several groups or categories. So if you have a whole bunch of people, let's say everybody in the AP Stats class, we are going to, and we're looking at their eye color, they would place the individual into one of the eye color groups. So the values of the categorical variable are the labels for the different categories. Okay, so for example, if we were doing eye color, so the value of the categorical variable isn't necessarily numerical value, it's the label that we're putting it in. Eye color is blue, green, brown, black. Maybe you have the crazy contacts in your eye color. Okay. Also keep in mind that when we do, if we were organizing by area code is numerical, but it's not quantitative because I cannot do any I can't find the mean or median, I can't find any averages, I can't do anything mathy with it. So the value of that categorical variable would be the various area codes. Think about labels for your bins, 703, 502, 412, those would be your various labels, and they would be the values of the categorical variables. Okay, the distribution of a categorical variable lists the count or the percent of individuals that fall within each category. So distribution of a categorical variable, think about where basically we want to see how many people are in each bin. Okay, so this first example, we're taking a look at a radio station. So we're taking a look at a radio station rating service. So the radio station rating service places U.S. radio stations into categories that describe the kind of programs they broadcast. Here are two different tables showing the distribution of station formats in a recent year. Okay. So take a look at the first one. This is a frequency table. Here's the different types of radio stations, different kind of broadcasting. And the first one gives us a count, the number of stations that have adult contemporary music, adult standard music, contemporary hit, country, news. So we said categorical variables are always going to be either counts or percent, so this tells us the counts. The relative, that might be a new word, the relative frequency table, okay, that specifically is relative to the whole. So notice each of those represent a percent. So adult contemporary, 11.2%, okay, that would be taking 1,556, dividing it by the total to get the percent of radio stations within that first category. Okay, so what is the variable? The variable is the title of the values. Okay, so the format in this specific case. Okay, so the variable in this case is going to be, think about your bins. You'd have each bin labeled adult contemporary, adult standard, contemporary hit, country, etc. Okay, the values remember, are the labels on the bin. Okay, so the variable is the format. Each of the values are going to be your bin labels. Okay, and that a frequency tables tells us the count within each bin, whereas a relative frequency table, take a look at the percent, okay? This percent does not quite add up to 100. It adds up to 99.9. A way to check yourself with your relative frequency table is to check and make sure it adds up to 100%, because we do want to make sure 100% of our data is being represented. However, in this case, it doesn't. Well, why does it not add up to 100%? It's really close. Remember, you will sometimes often have round-off error when you're adding percentages. It doesn't mean you made a mistake when you're adding up your data. It's just the effect of rounding your answer. So if you had maybe rounded to 3 decimal places, maybe it would be like 99.999. So just keep that in mind. Okay, so what are different ways that we can display categorical data? Frequency tables, they can often be hard to read. They can sort of be difficult and they don't display the data very well. You're looking at a frequency table and you're just sort of looking at a bunch of numbers. So instead of displaying stuff in a frequency table, sometimes it can be easier to analyze a distribution by displaying it with a bar graph or a bar chart or a pie chart. Okay, so if you take a look at this, if we take a look at the bar graph, the count of stations is very easy to see what type of format each of the broadcasting stations use. So obviously we could tell very quickly that contemporary hit was not very popular, where country and news talk are the most popular. So it's very easy to analyze the distribution or look at the counts quickly and say, what's the most popular, what's the least popular. Where a pie chart always tells the relative frequency count, because it's always in terms of percentages, we can very easily look at these percentages and say, okay, this is a really small slice of the pie chart. Contemporary hit was not very popular. Where if I look at this section right here, this 16%, and say, okay, that was a news or talk station, that is very popular. Now keep in mind that pie charts are okay, so I'm sure you've heard the word histogram before, and I was calling the frequency count a bar chart, not a histogram. A histogram and a bar chart are two very different things. So on this link below, please take a minute and either click on it, or if it doesn't click, please right-click on it to read the Forbes article on how histograms are different from bar charts. Okay, so you'll need to keep that in mind whenever you're analyzing categorical data and you're creating a bar chart. How is it different from a histogram? All right, so what exactly is important in a bar chart? Remember, number one, each category is a bar. Okay, so think about each of your bins. So each bin is going to be represented by a bar. The bar heights are the counts or percents. Now, if I wanted to make this out of 100% and use percents, you can. You would just label this as percent, and you would put the percentage as your bar instead of the counts. The bar graph can often be better than a pie chart, since they can compare data measured in the same unit. So we're specifically looking at counts here, and we'll be able to we can measure two different types of data. If they were measured in the same unit, we could compare the bar charts. Whereas a pie chart, we're just looking at a percentage of things. Okay, so graphs can be good and bad. We want to make sure that the data that we have collected and analyzed is displayed correctly, so that the correct information is given to anybody analyzing the data that we've collected. So this is just a cute little comic, so just take a second and read it. Okay, it's just kind of funny. So you just want to make sure that you analyze your data correctly and make sure that your graph displays the correct information. Okay, so what are some good and bad things about bar charts? Bar graphs compare several quantities, so we could have different bar graphs and compare them. They compare the heights of the bars that represent those quantities. So once again, if we were, looking at radio stations in the United States versus radio stations in Japan and taking a look at the counts, we could very quickly see, okay, how does country in the United States compare to country music in Japan? How does country music in the United States compare to country music in New Zealand? It would be interesting to analyze. Currently in New Zealand, there are not very many radio stations that play country music. I've actually haven't found any of them. Okay, so our eyes react to the area of the bars as well as the height. So make sure your bars all have the same width. Don't make your graph misleading by making one of your bars wider than another. Please avoid the temptation to replace the bars with pictures for greater appeal. So don't try to make your bar chart too pretty. Make sure that you're actually using bars, and sometimes if you're using software, you could replace, if we're looking at radio stations and we're doing country, with a guitar or a microphone for the talk show. Don't do that. Just make sure that you're using straight up bars. Keep it simple. Okay, so just take a look at this. This ad for DirecTV has a couple problems. How many of them can you point out? So just take a minute, think about it, pause it, and then the next slide will go over what we think is wrong with it. Okay, so let's see. Did you find the correct errors? So let's take a look at these. So we're saying, oh, hey, DirecTV has 95 of your favorite channels. Dish Network only has 81, and cable TV only has 56. But the heights of the bars aren't really that accurate. 95 is not necessarily twice as high as the 56 bar. Okay, so according to the difference between 81 and 95 is much greater than the difference between 56 and 81. So that's the second major difference. If you take a look here, this has a pretty big one, but it's saying, between 81 and 56, there's not that big of a difference when actually there is. Also, the extra width for DirecTV is deceptive. So our eyes immediately go to DirecTV because it's so much wider than the other bar charts. So it's deceptive because they respond to the area, not just the height. So think about that as you're looking at commercials on TV or you see billboards. Are they representing their data correctly, or are they trying to make it a little bit misleading? Okay, so here's an AP exam tip. So you'll see these often. Don't forget your labels. So make sure when you're creating bar charts that you include horizontal and vertical labels as well as a scale. You could take a lot of time and create a beautiful graph, but if you forget your labels and your scales, you will lose points. So it's really important to make sure you include those. Okay. That's your photo, your school name, the city or town you lived in, the email address, and the cell phone number. And make sure you write % of teens who post, not just %, because what is it a % of? Okay, and then you labeled your bar charts, and you just put the percentages in. Okay, so make sure you label type of information in each of your bins, and notice how there's these spaces between your bar charts. Okay, most bar graphs have spaces between them. Okay, now taking a look at letter B. So could we use a pie graph? No, we could not use the pie graph in this specific situation because the data that's represented in this situation is not a % of a whole. Okay, it represents different types of information, not parts to a whole. So for a pie chart, remember the percentages have to add up to 100. Where in this case, we had a whole bunch of students, we surveyed them, and then out of all of those students, we said what % took photos of themselves, what % used their school name, what % showed what city or town they lived in. If we took all of the students and said what % used Twitter, Instagram, and Facebook, then we could make a pie chart because it would be a pie chart of all of the students, okay, and then just dividing that 100% into 3 categories. Where here, that 100% was divided into multiple categories because one person could have done all 5 of these categories. So it's important to make sure you have accurate graphs. Don't try to make a pie chart when it's not necessary. If you could just click on that link below, you can either right-click on it or click on it to take a look at what both good and bad graphs look like. It's kind of funny, so take a look at that if you have the chance. All right, so we talked about at the beginning what is a two-way table. We're going to take a look at something called two-way tables and marginal distributions. So when a data set involves 2 categorical variables, we begin by examining the counts or percents in the various categories for one of the variables. Okay, so what are we talking about here? All right, so a two-way table describes 2 categorical variables. They organize the counts according to into a row variable and a column variable. Okay, so that's like taking a survey and breaking it down, such as the males are going to answer a question and the females are going to answer questions. So that would be 2 categorical variables. Or the 9th, the 10th, the 11th, and 12th graders are going to answer a question. Okay, so that would be more categorical variables. Okay, so let's just take a look at this quick graph. All right, so what this graph takes a look at is we did a survey of 4,826 randomly selected young adults aged 19 to 25, and we asked them the question, what do you think the chances are that you will have much more than a middle class income by age 30. So this table represents the answers to those questions, okay? So this is a two-way table because it describes 2 categorical variables, all right? Gender and opinion about becoming rich. Okay, so here's the gender. We took a look at 2 things. Okay, we said we separate it by male and female, so that's 1 categorical variable. So we put every person into that first bin, and then after putting them into that first bin, we took a look at what are the chances of being rich. Okay. All right, so our opinion, so what are the variables? The row variable here is our opinion of getting rich. Okay, no chance of getting rich. Some chance, a 50-50 chance, a good chance, or almost certain. What is the column variable? That's the gender. Okay, so think of the whole variables like what could I label both of those together, gender, what could I label this whole thing right here, opinion. And then at the bottom here, this is really important, you always want to be able to find that total. The total number of adults surveyed are always going to be in this bottom. Now keep in mind, remember that the total for the rows should also equal the total for the columns. So that's just a quick check to make sure that you did that correctly. All right, so what exactly is a marginal distribution? So the marginal distribution of one of the categorical variables in a two-way table is the counts of the distribution of values of that variable among all the individuals described by the table. Well, what does that mean? Okay, so the marginal distribution is literally just taking a look at one of the rows or one of the columns in comparison to the total. So marginal is always comparison to the total. All right, so just a quick note, percents are often more informative than counts, especially when we're comparing groups or different sizes. So what percent of females think that there's no chance of getting rich versus what percent of males think there's almost no chance of getting rich. So that can tell us more information than just how many males or how many females, because that doesn't really give us any comparison to the total. So marginal distribution is always comparison to the total. So to examine a marginal distribution, you use the data in the table to calculate the marginal distribution in percents of the row or column. So it's just taking that row divided by the total, that specific column divided by the total, and then we can make a graph to display the marginal distribution, or the distribution of just one of the variables in. Okay, so let's just take a minute and look at the marginal distribution of chance of getting rich. Okay, so this right here, this whole thing of chance of getting rich. So the marginal distribution always compares to the total. Okay, so we're comparing it to the total. So specifically we're looking, when we said the marginal distribution of chance of getting rich. So that's basically saying what percent of the total thought there was almost no chance? What percent of the total thought there was some chance? What percent of the total thought there was a 50-50 chance? Okay, so the marginal distribution is taking a look at the total of that row, which is 194, divided by the total of the entire table. Okay, so what percent thought that there was almost no chance? So 4%. Yeah, that's pretty low. Some people said, oh, there's some chance, 14%. A 50-50 chance is about 30%. A good chance of getting pretty rich, same thing, about 30%, and almost certain. So that's much easier to take a look at that distribution and say, what percent of people think that they're going to get rich? Then what you can do is take that and create a bar chart out of it. Once again, notice the labels and the scales. Okay, so we have the labels here of all of my values of the variables, and then here we have the percents. So marginal distributions actually tell us nothing about the relationships between two variables. They only tell us about the relationship to the total. Let's say we wanted to compare the distributions within my two-way table. A conditional distribution of a variable describes the value of that variable among the individuals who have a specific value of another variable. Okay, so that's a lot of words. What does that really mean? So a conditional distribution really is just taking a look at how do the males compare to getting rich to the females. Okay, so it's taking a look at two of the variables within your table and then comparing them to each other. So we're not necessarily with a conditional distribution, we're not going to be comparing them to the big total of the table. Okay, so how do we find or compare conditional distributions? So we select the row or column that we're looking at. So we're either looking specifically at male, female, or chance of getting rich. Okay, we're going to use the data in the table to calculate conditional distributions in percents of the rows or columns, and then we make a graph to display the conditional distribution. So how we would do that, that's basically like taking a look at a side-by-side bar graph. Okay, so two graphs right next to each other, and I'll show you what a segmented bar graph looks like in order to All right, so take a look at these directions. It says calculate the conditional distribution of opinion among males. Okay, so conditional distribution, I'm looking specifically of opinion among males. So what is going to be my denominator here? It's not the total. Since I want to look at the distribution of opinion among males, basically I want to see what percent of males have each specific opinion. So that tells us that the male in this case is the denominator. All right. And then what we're going to do is we're going to examine the relationship between gender and opinion. So that means we're going to not only find the conditional distribution of male, but the conditional distribution of female. This total column will often not be given. Please make sure that you find it the first thing if it is not given to you. Okay, so what's the conditional distribution of opinion among male? So basically we're going to say, okay, what percent of males thought they had almost no chance? What percent of males thought they had some chance? Okay, so I know that 98 males thought that they had almost no chance. That is out of the total number of males, 2,459. Okay, so males is always your denominator in this case. And then what we could do is we can make a bar graph out of that, the same way we did before. Okay, but remember our goal is to examine the relationship between gender and opinion. So we've looked at what percent of males think they're going to get rich, some chance, 50-50 chance, good chance. Okay, let's see how that compares to the female. So who's more confident about being rich? Okay, so let's take a look at the conditional distribution of females. That means that the female is going to be the denominator. So almost no chance, 96 out of 2,367. Okay, now we can put the bar graphs together as a side-by-side bar graph and say, actually, males and females have about the same opinion about whether or not they're going to be rich. There's only one major difference here. It looks like the males have a higher, they think that they have a better chance of getting rich than the females do. We can also use a segmented bar graph. So what is a segmented bar graph? All a segmented bar graph is taking each of the percentages and stacking them on top of each other. So if you take the very beginning, so males, 4%, so that's represented 4%. Some chance was 11.6, so then you're going to start here and make sure that this represents 11.6%. Okay, so then 50-50 chance is 29.3, so then you'd have to start here. Make sure you calculate what this is 29% here, so on and so forth. Then it's also very easy to see right next to each other which percentages are greater. This should always add up to 100% because we're looking at 100% of the females and 100% of the males. So if you feel like you are still a little bit confused, I apologize. Just went back. Take a minute and watch the video by clicking on the link below or right-clicking on the link below to help explain the difference between conditional and marginal distributions. So just remember, keyword, marginal distribution is going to be always a comparison to the total. A conditional distribution, you're placing a condition on it. Opinion among males. What is the condition? The condition is that I want just the opinion of the males, therefore males is going to be my denominator. Okay, so what does association mean? So is there an association between gender and an opinion of getting rich? Okay, so what exactly does association mean? There's an association between two variables if knowing the value of one helps predict the value of the other. Okay, so it just helps us predict. So knowing whether they're male or female, does that help us predict whether they think they're going to get rich or there's not really a good chance of getting rich? If knowing the value of one does not help you predict the value of the other, then there's no association between the two variables. Okay, so if knowing whether they're male versus female, if that doesn't help you predict whether they think they're going to get rich or not get rich, then there's no association between the variables. However, this is really important. Please do not state that there is a correlation between the two variables. This is going to be specific to linear relationships between quantitative variables. So all association means is that if you see one variable, it can help you predict the other variable. It does not mean, association does not mean causation. Okay, so just because there's an association does not mean that there's causation. So just because I know that they're male, being male doesn't cause you to think that you're going to get rich or cause you to think that you're not going to get rich. We'll take a look at that in a later section. Just because there's an association between young males and the fact that they think they're going to get rich does not mean that if you're a young male, this caused you to think you're going to get rich. Please be careful with that. We will specifically look at that later when we take a look at linear relationships. Okay, so association does not equal causation. You'll hear that over and over again in statistics. Okay, so just a quick summary. In this section, we learned that the distribution of a categorical variable lists the categories and gives the counts or percents. Okay, see if you can take a minute and just fill these in. So what two types of graphs do we use to display categorical variables? What kind of graph allows us to look at the number of counts and organize that into two categorical variables? The row totals and column totals in a two-way table give the what? Okay. There are two sets of blank distributions for a two-way table. Okay, so a two-way table, what kind of distribution? Here's our summary continued. Just remember, we can use a side-by-side bar graph and a segmented bar graph to display conditional distributions. To describe the association between the row and column variables, compare an appropriate set of conditional distributions. Even a strong association between two categorical variables can be influenced by other variables lurking in the background. And we'll take a look at that more a little bit later. You can ignore this last step right here. We'll be going over that in a later section. Okay, so if you want to check out some more examples, make sure that you go to underneath this video. Make sure you go underneath it and take a look at the practice problems that you can do. You can also click on the two links below or right click and they will give you some practice on making bar charts and